Let's test and see if we have a different result. You can see straight up we have light straight up. So now, like, can you see? Off, on, off, off, on. You see, we have a working board now. Hello. Today I have another dead laptop, and I've tried connect the charger, tried battery, still remain dead. It's not showing any sign of life at all, so it means the board is dead. So before I begin the diagnose, I would like to confirm we have the input footage or the input requirements. Ground, measuring the input footage from the DC jack. You can see we have 19, which is good. So pressing the power button here, nothing, no any sign of life. And measuring the footage from the power switch, you can see we have 3.2 volts, which is good. Now pressing the power button just to make sure if the power button is actually working. You can see the footage on the multimeter, it goes down, so it means the power switch is functioning normal, and the problem is something else. So now what could cause a motherboard to dead? It can cause by a lot of things, a lot of reasons, different things, but as a technician, how to repair it is the most important. First of all, because a dead motherboard laptop or a dead motherboard of any electronics can cause by many things. For any technician, the best way to handle a situation like that is just to go back, like always go back to the basic, how it works. Because if you don't understand the basic, there's no way you can actually become an expert technician. So you have to understand how it works, and that is it. That's just the major key. Now we have the input power, and at least we can confirm we have 3 volts on the power switch. Is either we have the charger, is either we have the battery. So at least we just need one source of power input. So right now I don't have a battery connected to this laptop, but I have a charger. So it means I have VCC, and at least I can confirm the VCC is good enough to the extent that we even have the second layer of power supply, which is 3 volts. because 3 volts is 3 volts tap from 19 volts or from the main VCC. So without main VCC, there's no way we can have 3 volts. And you know, main VCC, which is 19, 15, 12, or like after that, the standby section, which is 3 volt, 5 volts. Then after that, we will have different voltages, 1 point something volt, 0.9, like everything come after each other. So next thing, if you want to do it proper, next thing is just to confirm if you have 3 volt, 5 volts. Normally in some other in some other architecture, once you have 19 volts, you will have 3 volt, 5 volts, because the 3 volt, 5 volts does not need any outside chip or any outside controller to enable it. The enables is within itself, is within the chip itself. So straight, unless if there's problem, if everything is okay, after the 19 volt, 3 volt, 5 volt must be present in some architecture, and in some other architecture 3 volt, 5 volts will not work unless the controller, there's another controller, and mostly is the IO that will enable 3 volt, 5 volts. And in this case, the 3 volt, 5 volt chip will not have the output unless the IO is okay. So let me show you on the schematic. You can see this is one of the power input. Is it that power adapter like charger or the battery? One of these inputs must be present. Now the next thing, if you have VCC, next thing, check if you have 3 volt, 5 volts, and you can see I have 3 volts. This is how that 3 volt come. This 3 volts is 3 volts is 3 VA, which come out of this chip, and is VCC for IO, not 3 VSUS. No. So power button come out of IO, and once IO receive VCC, and in this particular motherboard they name it 3VA, so there will be voltage on power switch, and there are some other places you will find 3VA. So that doesn't mean there is 5 volts and the 3 volts is different. First of all, once this power, charging IC receive AC bat and the PS on, which is the enable for the for this 5 VA, the 5 VA will be generated and is the input for this chip, which will output 3 VA. Then 3 VA again is input for IO and some other chip. So now we have this number 6. It means all the way from number 2 we are all true, because if there's any issue, there's no way we can jump to this number 6. This number 6 will not be present. So we cover 1 2 3 4 5 6. Now 7 is what we need to check, then 8 and 9. Okay, so I'll remove the motherboard now and check some footages to confirm. Again, let me confirm. So still on the power switch we have 3 volts and still the board is not coming on. Now I'll just remove the motherboard and test some footages, then see where we have problem. The board is so the board is out now and trying to check some footages. First of all, there are some architecture that you need to press power button before there will be 3 foot 5 volts. So but before I even okay, so I've connect the charger again, then trying to check but the problem or little problem here is I don't have board feel for this motherboard, and this motherboard is not labeled, so it's not really easy like that to locate every component, but I will just try my best and see what I can do. Okay, okay, again, just nothing. No. 39A12, and this is it on the board, so I can locate the charging IC easily. And even though my problem is not the charging IC for now. Yeah. Okay.
Okay, so at least you can see MB39A132. So that's the power IC. Then, as we know, we cover 3, 4, 5, 6. So what we need to focus now is the 7, which is the enable signal, or we just go straight to 8 and 9, or even 8. So because we don't have the uh, board feel, I will just try to repair it based on experience, and let me suggest or think maybe one of these chip is the output for, but I don't think so. But I will just try to measure around and see what I got. We have, okay, we have 3.3 foot here, and let me see the other one. Damn, God, we have 5 foot. No problem. So we have 5 foot, and we have 3 foot. So it means the step 8 is complete. You don't even need 7 again, because without 7 there would be no 8. So we are good here, and I'll just believe number 9 is also good, because it's just like a feedback. Not it's just, it is a feedback telling IO that 8 is good and clear. So I'm sure we don't have problem with number 9. Now moving on. Yeah, what is the next step? There, not every schematic you find it labeled like this, number 9 or number no. In some other schematic, they use different techniques to this is called power sequence, and in some other schematic they can use different techniques to analyze the power sequence. So but it's this, like this one is very easy, very easy for beginner and everybody. So now 10, which is ECRSMRST, and it's a signal out of IO. It is a signal out of IO. So number 9 too is a signal out of 3 foot 5 foot chip. So before we can have this PM RS MRST, these two signal must be okay. Now it will be somehow challenging, like I said earlier, because I don't have board feel, and this board is not labeled. But trust me, I will just find a way to deal with it. Now what I will do now is, because this 10 ECRSM is out of IO, I'll just go straight to the IO section, then look for the pin, because looking for this chip, which is it can be somehow time consuming. So I'll just go straight to IO and check if I have this 10 out there, which is, you can see this is IO, and you can see it's coming out of it. So once I have it here, then I believe it's cool. Then I'll just move on to next thing. Alright, let's go. And where is it? So alright. Okay, we have it page 1, 2 and page 24, and we are already on page 2, so page 24. So this is IO schematic, and we are looking for the EC, they call it, okay, pin 74 EC RSM RST is coming out. Pin 74. Let me quickly check pin 74 and see what I got there. From this side, this is pin 1 and 32, 64. We have 96 here, and I'm looking for 74. 74. All right. So this is 64, 65, 66, 67, 68, 69. Okay, 64. Oh. 5, 6, 7, 8, 9, 10. That is 70. 1, 2, 3, 4. Okay. You can see. Aha. There is output there. So there is output. So we have 10 and 11. 11 will be somehow add, and this signal too, I think, is going back to IO. You can't see. No. It's not. I cannot find this thing easily. I cannot find it. I can't. No. I cannot find it. But I think it's going back to IO. PM. Or if it's not coming to IO, then it's going to PCH. 11. Yeah. Where is 12? 12 is power switch. So if number 11 is not okay, there's no way we'll have 12. And power switch, already I've checked it before, we have footage there, like correct footage there. Let me check it again and see. 3.2 volt is okay, so it's good. Now 13. Where is 13? 13. Okay, you can see 11. I told you, if it's not going to IO, then it's going to PCH, and this is PCH, so this is where it comes. So no problem. I think 13 should be around. Okay, yes, you see 13. That is 13 is PM PWRBTN. That is power button. Is it 13 is once you press power button, I will send a signal to PCH. You can see power button switch is 12 and 13 is pressing the power button. A signal will go to PCH. Then 14, PCH will send two signal back to IO. You can see these two signal SUSB and SUSC, then 15. So after these two signal 14, then there will be SUSB on 15, another signal, another two signal 15, then what next? 16. So that is when the system will start working completely. So this 16, this 5 volts, I mean this 16, this chip UP6111 is VRM chip. That is a power supply for CPU. So what I need to confirm now, we have 12 volts. Do we have 13 and 14? Because after this 14, the system is supposed to come up, unless some rare cases, some special cases that you need to go deep. But normally that is how it works, unless there's a problem with the IO. So we have 12. Let me confirm 13, which is PM PM underscores PWRBTN. So let me check it from the IO. I can say this is pin 25 is, but that will only be available after you press power button. Power button must be pressed. I have one here, one, this is 25, and this is 32. Okay. From this side, this is pin 1 and this is pin 32. So 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. 1 2 3 4 and 5. Let me press the power button. We don't have any signal there, nothing. I'm pressing the power button right now, we don't have. So we have to question the IO, and that's it. The IO is our number one suspect at this point. 20 again. 1 2 3 4 5. Nothing. And where is it? You don't have anything there. Okay, but one thing I suspect right now is I can spot some corrosion on the IO itself. You can see I can spot some corrosion, and you know what you can see this area, you can see, and this is pin 25, so you can see the area already, and you see other parts. You can see why we don't have power, or we don't have the output that's supposed to come out of pin 25. So
I will try to clean that area and see if that solves my problem. uh, Let me just clean the board completely. Maybe there is another problem somewhere, so just making sure everywhere is good physically. And, okay. So I will allow it to cool down for some time. Okay, I think it's cool down enough. So let's test and see if we have a different result. You can see straight up we have light straight up. So not like, can you see? Off, on, off, off, on. You see, we have a working board now, and this problem caused by corrosion on the IO chip, and you see how we narrow down to the root cause, to the main cause, to the real cause of the problem. So that will be all for this video, and thanks, and make sure you subscribe to follow this channel so you keep learning. We are all learning, and you understand, like, so whenever we drop a new important video, you don't miss out. So thank you.